Well, today in the shop I've got a very cool Kenwood KR-4200, and it's from around 1974, 1975, and it belongs to a friend of mine. He's owned it since he bought it brand new, and he's used it all these years. And what happens is that when it warms up, it cuts out. And he says it's both speakers that are cutting out, but I'm going to check that. It looks like it's in pretty good condition. The wood, I couldn't wait to take the top off. I had to take a look at it and see what was inside, but everything looks pretty nice on it, a little bit dirty. But so I'm gonna set it up on a dummy load and turn it on and see if I can figure out what's causing the sound to die out. And then once I get that working, I think I'm just gonna generally go through it and replace some capacitors and see if all the transistors are good, and just kind of do refurbish it a little bit, make sure all the lights are working and stuff. So, because I think it's really a beauty. It's a nice looking stereo. I think it's only about 20 watts per channel, but we'll see that as well. So we can see here's the power supply board, the power transistors, the power amp. I think that's the preamp board, but I'm not sure. And yeah, so it's a pretty straightforward receiver. Let me plug it in. So you turn it on. It's got a very nice looking front. It's kind of dirty, of course, but separate power switch, which I like. Bass, treble, balance, volume, and selector, and then some kind of interesting looking buttons here. Yeah, that's kind of interesting, the loudness and the noise filter. Anyways, so let me get it hooked up and we'll see what it's putting out. So I'm putting in a 1 kilohertz wave at about 300 millivolts peak to peak. And I'm just coming into the aux port here. And then I have a couple of big 8 ohm resistors stuck to a heatsink. And then I have my scope probes coming off the two different dummy loads. And interesting, hardly getting anything through the one channel. The other channel seems to be working fine. Let's see which channel it is. So left channel's working, right channel's not. That and that balance pot seems kind of screwy there. But yeah, so I think that's the first thing to take a look at is the report is that it would run for a while and then cut out, and it may still do that, but it looks like it's only working on one speaker as well. So the channel's good. I'm putting a square wave through it, and it's really looks like it's cutting off some of the frequencies from the square wave. I'm not that familiar with how to use a square wave, but it should be much cleaner. Alright, so I'm hooked up to the signal generator, and you'll notice the two different hooked up to the right and left channel of the speakers, and you'll notice that one of the channels is quite a bit lower than the other, and I still haven't seen it cut out the way the owner said it was cutting out. But I noticed that when I kind of flex the board a little bit, so it looks like it might be right in here that is cracked, but I'm not sure. I'm going to redo all of these. But if I touch in here, you can see the waveform change. So I want to fix that first. Okay, let's see if that makes a difference. Nope. Alright. It seems to. I don't know. Let me clean up this volume knob. I'm going to clean up all these controls. They're not great. So resoldering didn't seem to help it, seemed to kind of make it a little bit worse. Well, I keep thinking I found it, because when I press up here, I get some change in behavior. But the other thing I find is if I had touched this orange wire, which is the input to the tone board, that looks like it's the problem, but why would touching this board up here also make a difference? I don't know. So this is coming right out of the tone board. You can see that they're off. Well, I don't know. I'm connected right to the input, and much as I pound and do things, I can't get that weird. I kept thinking maybe it's a wire in here. I can't get it to bounce the way it was on the other one, but if I connect down here to the output, I get that happening quite a lot. And if I touch all kinds of things on this board, I was getting the same thing over here. If I touch it over here, it looked like it would jump around, but there's something about this board. And I thought it was this wire here, this input wire, but yeah, so there we're seeing those waveforms are off. And there I just barely touched something, and it fixed itself. So I'm going to have to take this board out, and it might be a solder joint on the volume, because I mean, even small tap on the volume. Yeah, it might be. But any of them will do it. Well, it does look like these solder joints are, looks like they've got tiny cracks in them. I don't know, I'm going to resolder these. I'm going to trade out the capacitors and see if we can get this thing working right. Okay, so here's where we're at. I recapped the tone board and fixed there were cold solder joints on the volume, and that was causing that the two waveforms to not match up. And here, if we look at the capacitors, old phone parts, if we look at the capacitors that I replaced, these orange ones didn't seem too bad. These seemed worse, and in fact they have a terrible smell to them. And these two things were not working at all. And so I replaced all those. You can see them here. And now the tone board, if I turn up the volume here. Whoops, no. So then if I look at the output's nicely matched up. We're not seeing any of that separation that we were seeing before. So now, once we've got that, and we've got quite a bit more output than we had before, and which is good news. I think when you turn it up, your output goes to about 2.2 volts, which is quite a bit more than I was seeing originally, and it's a lot cleaner too. But that's because the output's higher. And so then if I come over here and look at, so this is the input to the tone board, this is the output, super easy to get to. Then if I go to the output of the power amplifier here, you can see I've got some DC offset right away, and then when I turn up the volume, you can see that there's quite a bit of difference between the two waveforms. This one's got DC offset, and so there is work that we have to do in that on the amplifier board. And when I researched this, I looked, and the two input transistors, let me show you those. So there's our waveform again. Even when I mess with the transistors, they've got a weird black coating on the legs, which is bad, but even when I kind of mess with them a little bit, you'll see the waveform switch. Let me just get a little bit of alcohol and spray it on there, or put it on there, and you can see when it cools off, you see that going all over the place. So I'm going to replace these two transistors and see what kind of a difference that makes. Okay, so here are some of the transistors I replaced in the in that first long-tailed pair coming into the amplifier, and you can see Look at the legs, how they're all black. And there's their replacements right there. And and right here. And so we'll flip it on and we'll take a look at the waveform. Okay, so right away we see that the offset is we see that the offset's very low, right at 0. And then if we turn up the volume, they're still a little bit off, but you can see they're tracking pretty close together, and you're not seeing any of the weird behavior that you were seeing before. And so that's looking good. Those things seem to be working pretty well. I haven't adjusted the bias on it yet, but what I'm going to do is I'm going to replace the capacitors on the amplifier board, and then I'll set the bias, and then I think we might be good here. So when I'm replacing capacitors, one thing I found kind of handy is that I just set up a little laser, and then I'll point the laser right at the capacitor, like that. And you can see it shining there. But then on the other side, you can see right where it's at on the board. And it makes it much easier to locate the capacitors, because I've spent times unsoldering the wrong parts, and here you tend to get the right part every time. Anyways, it's a handy trick. Okay, so now I'm going to adjust the bias. And thanks again to Hop John on Audio Karma, because we want 18.8 millivolts across these two emitter resistors, and so I put in a new potentiometers here, and I've kind of let it warm up. We just want to turn these until we get to 18.8, and when I first installed them they were really far off, but yeah, that's all you really need for the bias. So I'm just looking at 18.9 millivolts over here, and I've let it warm up for a while just to make sure it's right. And then on the other ones, then for the other two emitter resistors, we want to hook up right there, and then right around 18.8. And like I say, you want to let it warm up, because when I first did this when it was cold, and yeah, it changed drastically once it warmed up. So now if I crank the volume right up to clipping, so if I go to clipping and then back, I'm right at about 13.12 volts RMS. So if I square 13 and divide by my dummy load, which is 8 ohms, I get about 21 watts, which is right what the stereo is rated at. So everything's working great on it. So I have it running full out. If I look at my power transistors, they run about 90 degrees, 93, 91, 91. So they're really not getting that hot. Heat sink's around 92. Yeah, everything seems to be running pretty well. Given that I've got it cranked all the way. It looks nice and solid. I'm going to turn it down. and put a square wave through it. So I've turned it down quite a bit, and I'm just going to put a square wave through it. And you can see that the square wave, yeah, I think these pots need to be cleaned a little bit better. But it does show that we can flatten it out pretty well, where we weren't able when we before we recapped it. So I got my little bottle of oil. I'm just going to oil very carefully some of the tuner controls. Just put a tiny bit of oil on there. I took the faceplate and I polished it. So I've been running it for a while, and it sounds great. The tuner doesn't. It sounds a little bit dead. I don't know why. I'm gonna maybe pull these capacitors here. I'm gonna look at the circuit to see what capacitors are kind of associated with. See if there's anything that are acting like coupling caps. And these orange capacitors, they all seem pretty good. The gray ones didn't seem as good. I suppose I'm going to recap this and put new filter caps in it. And so that's the next step. I got the face on and just polished up the plastic with some of this stuff, which works pretty good. And so one thing that's kind of weird about this stereo is the volume knob. I tried to get it out, and it's got this shaft like this, which I don't quite get. And I tried to get it out like I do the other ones, but it doesn't come out there. That's almost fused in there. And it's like the whole shaft slips out. I don't know if anybody's got experience with whether you just pull these out or what you're supposed to do. It does slide in here and slide into place. It seems pretty good. But yeah, it just seems kind of weird. So if anybody knows how to get these out, if it's just pulling them out like I had to do, or if there's a better technique, make a comment on it. I'd like to hear it. So I want to do a little experiment. I'm kind of looking at recapping the tuner board, and these two little capacitors right here, there were two small capacitors, white capacitors, in the tone board, and they were not very good at all. The gray ones tend to be marginal, and the orange ones all seemed good. And so I should probably replace those, but I want to see if it makes a difference in the tone quality. So I'm going to do a little experiment. So those two capacitors are right here and here. And they're coming right out of all these diodes, and I think so the signal goes right through those two capacitors, and then goes out into the main amp, and so they're right in the signal path. All these other capacitors are not, and so those two capacitors are kind of important. But it'd be kind of fun to see whether it makes a difference. So I have this little app that can create white noise, and right now I have it just putting out a sine wave at 1000 hertz. Then I have an FFT set up right here. Here you can see the sine wave. I have it kind of connected to the speakers there, and yeah, so I mean, a characteristic of a sine wave, you just have the jump in the frequency right at 1 kilohertz. Okay, so here we can see our FFT, and it's not on dB, it's actually on volts. As you can see, we have some lower frequencies are passing through, but it does seem to kind of degrade as you get into the higher frequencies. So I'm just going to change out those capacitors and we'll see if that signal changes. And I have that tone generator just coming into a little FM transmitter here, and then we're just picking up that FM transmitter. So those are actually 0.47 microfarad, and they didn't test great, but they didn't test too, I mean, they weren't clearly bad. But then if you look at the signal, I don't know, looks a little better. It doesn't dip down quite as much, but I don't know, I thought it was worth taking a look and seeing if it would make a difference, or if we could see a difference in the performance. I'll have to hook up speakers and see how it sounds. So the top of the stereo, kind of a nice walnut looking plywood, but it's broken, and I can see why. There's just not really much there to hold it, so I'm going to cut these guys off and I'll put some other pieces in there, and then glue these two pieces together, and then I'll glue these cleats back in. So we're just putting down some strips of tape, and that'll just hold the joint together. And we glue. It's kind of banged up where it broke, but let's see if we can turn this on a flat surface. Then we should be able to tip it up like that, get a good adhesion between the two sides. Tip this up. Alright, so that should be nice and square. Looks like we're also kind of separating up here. So I'm going to try to get a little glue in there. Yeah, so this is kind of crooked in here, so I'm just putting this piece of wood against it here, and I think that should hold it in place. And that should be good. I'll let that dry, and then I'll glue a couple of cleats in here.
Depends on membership eligibility. Membership eligibility.
Well, here it is all back together. It sounds pretty good. I turn on auxiliary here. So let's look at the FM.
All-wheel drive redesigned
It has really good reception. I'm in a basement here, and I just have a little wire antenna on there, and the reception's really good.
Take a look at the desert. Do you feel like a grain of sand?
O'Reilly. Get your
Yeah, so I'm really happy with how it came out. I love the stereo, and like I said, I fixed it up for a friend. And problem, just to kind of recap, the problem was the capacitors that leveled the line in the front of the power amplifier. That was one problem. Another problem was some of the capacitors in the tone section were bad, especially in here there were white, gray, and orange capacitors. The orange capacitors were all good, the grays were kind of sketchy, and the white ones were all bad. So the white ones were low value ones, and so I replaced a bunch of them. Replaced them in the phono section and the main amplifier, and I also replaced the caps in the power section, although they seem pretty good. So that's all I have. I like the stereo a lot. Sounds like $1 million. So anyways, if you like the video, please hit like and subscribe. And there's more videos like this coming up. Like I say, I love to fix things. Thanks for watching.